Let's work on graphing rational functions. A rational function is a function whose rule can be written as a ratio of two polynomials. Ratio is going to look like a fraction. The parent rational function is f of x equals 1 over x. Its graph is a hyperbola, which has two separate branches. So to graph the parent graph, what we're going to do is we will start with kind of a black hole at 0, 0 that our graph is not allowed to touch, and then we'll have the point 1, 1. If we put 2 in for x, we get 1/2 out. If we put 3 in, we'd get out 1/3. If we put 1/2 in, we'd get out 2. If we put 1/3 in, we'd get out 3. So this graph has a branch up here. We've worked with these before. And then a graph in the third quadrant, -1, -1, -2, -1/2, and -1/2, -2. So we get two separate branches of this function. The domain of this function, if we scan left to right, takes on every x value except for 0. So the domain will be -∞ to 0, skip over 0, and go 0 to infinity. The range, if you scan bottom to top, goes from -∞, skips over 0, and goes to infinity. So -∞ to 0, 0 to infinity. That pattern for growing, let's write that down. Remember, there's a black hole at 0, 0. And then we go over 1, up 1, over 2, up 1/2, over 1/2, up 2, and then we go left 1, down 1, left 2, down 1/2, left 1/2, down 2. This graph has a black hole. Let's put that there. It's not really a black hole, but that's what I just call it. The line x equals 0 is a vertical asymptote, and the line y equals 0 is a horizontal asymptote. And an asymptote is a line that a graph approaches but never touches. Okay, this is our parent function. So for hyperbolic rational functions, what we're going to do is we'll use that parent and some transformations to graph other hyperbolic functions. So here's your reminder. Changes to the equation of the parent graph are no different from any other changes we have looked at this year. For example, when we graphed f of x equals 2 times the quantity x minus 3 squared plus 4, we shifted the graph of y equals x squared, which was the parabola. This was right 3, up 4, and we had a vertical stretch of 2. These same changes will occur when we graph rational functions. So in this rational function, this x minus 3 is down in the denominator, so that's a shift right 3. Plus 4 is outside the parent function, so that will be up 4. And this 2 in the numerator is a vertical stretch of 2. So let's look at a couple of problems here. Let's look at these functions here. Let's talk about the transformations. Here I have a shift right 3, up 4, and a vertical stretch of 2. So that's the function we just talked about up here. Now if we shift that parent graph right 3 and up 4, what's going to happen is that black hole will be shifted right 3 and up 4, so it will be at 3, 4 instead of 0, 0. Now this black hole is what gives us those asymptotes. So I can kind of draw kind of like a crosshair through that black hole point, and that's going to tell me that my vertical asymptote is at x equals 3, and my horizontal asymptote is at y equals 4, because I've shifted right 3 and up 4. The domain for a rational function is going to just skip over the vertical asymptote. So the domain will go from -∞ to 3, and then we got to skip over 3 and go from 3 to infinity. And the range, we'll skip over the y value of the horizontal asymptote, so negative infinity to 4, and then 4 to infinity. When we go to create this graph, we want to use the vertical stretch along with the patterns for growing. So normally we would go over 1, up 1, but now we need to multiply that times 2. So we'll go over 1, up 2 from the black hole. Normally we'd go over a half and up 2, but now we've got to multiply that times 2. So we'll go over a half and up 4. And we'd normally go over 2 and up a half, but we're going to multiply that by 2, so we'll go over 2 and up 1. And that gives us the branch up here. And then we'll have that same pattern down in what would be the third quadrant here. So we'll go left 1, down 2, left 2, down 1, and left a half, down 4. And that will give us our other branch of the hyperbolic function. Finding the x-intercepts, what we're going to do to find x-intercepts is we're going to set y equal to 0. And since y is represented by g of x, we're going to have 0 equals 2 over x minus 3 plus 4. And we're going to need to solve for x. So I'll start by subtracting this 4 over. So now I have negative 4 equals 2 over x minus 3. Then to solve for x, I'll go ahead and multiply both sides of this equation by x minus 3. So the x minus 3 cancels with that x minus 3. And I have negative 4x plus 12 equals 2. And I can subtract my 12, so I get negative 4x equals negative 10. And then divide by negative 4 gives me x equals 5 halves. So my x-intercept will be at 5 halves, 0. And when I look on my graph, 5 halves is 2.5, so over 2.5, and it's right there, just like we showed using our transformations. Let's look at this second example. I want to start again by listing the transformations. So I have a shift. Inside here means left and right, so this is left 2, this is down 3, and then I don't have a stretch, but this negative out in front means I have to reflect over the x-axis. So all of my ups become downs, all of my downs become ups. So I will start by shifting my black hole left 2 and down 3. So from 0, 0, I go left 2, down 3, and that gives me those asymptotes, like a bullseye, right through that black hole. So my vertical asymptote will be x equals negative 2, horizontal asymptote y equals negative 3. Domain, again, we're just going to skip over the vertical asymptote, so we'll go negative infinity to negative 2, or negative 2 to infinity. The range, we'll skip over our horizontal asymptote, so we'll go negative infinity to negative 3, or negative 3 to infinity. Let's use our transformations to graph. So the only thing I'm doing is I'm changing, instead of going over 1 and up 1, I'm going to change that to a down 1. Instead of going over 2 up a half, I'm going to change that to down a half. Instead of going over a half up 2, I will now be going over a half and down 2 to get that reflection. So I'll go over 1, down 1, over 2, down a half, over a half, down 2. And then the same thing, where I would have gone left 1 and down 1, now I'm going left 1 and up 1, left 2 and up a half, left a half and up 2. So I get my other branch here. Now let's see what we find out about x-intercepts. Again, we start that by setting 0 in for y, so I have negative 1 over x plus 2 minus 3. So I will add my 3 to the other side, so 3 equals negative 1 over x plus 2, multiply by x plus 2. That gives me 3x plus 6 equals negative 1. Subtracting the 6 gives me 3x equals negative 7. Dividing by 3 gives me x equals negative 7/3. So my x-intercept will be at negative 7/3, 0. 7/3 is a little bit bigger than 2. It's like 2 1/3, so looking here I have negative 2 1/3. My graph matches.